Our next example, a scale model of a blimp rises when filled with helium to a volume of 55.0 cubic decimeters. Deci is not a prefix we use a lot, and in this problem it turns out to not really matter that much, but it turns out that a cubic decimeter is actually just equal to a liter. So it's kind of a weird way of writing it, but that is actually the way it works out. But notice that your other volume, if you read ahead here, is also in cubic decimeters, so as long as the units are the same, it's fine. When 1.1 moles of helium is added to the blimp, the volume is 26.2 cubic decimeters. How many more grams of helium must be added to make it rise? We're assuming constant temperature and pressure. So, if we look at what's given in this problem, we start off with a volume. Even though the unit's a little odd, we are still given a volume. And we actually, we don't know anything there. So now it says when 1.1 moles is added to the blimp, we have another volume now. And so this is an interesting one because your other V actually comes first. But what we really have here is an initial set of conditions. 1.10 moles is when the volume of the blimp is 26.2 cubic decimeters. And it says how many more grams must be added to make it rise. So we need to figure out our N2, and that's when V2 is going to be 55, because it tells us that in order to make it rise, we need to get it all the way to 55 cubic decimeters. So this problem is a little bit interesting in the way that it's worded. You have to be a little bit careful when you read through it to extract the information properly. It doesn't really matter which set is 1 and 2, but the important thing is that this N and this V, the 1.1 and the 26.2, go together. So they are a set of conditions. And so whether that's N1 and N2 and V2 or whichever, it doesn't matter. But the 1s and 2s aren't important as long as whatever one you assign the 1.10 moles, that same one is for V. So you could make both of those N2 and V2 and then make your V1 55 and your N1 is the one you want to find. So it doesn't really matter. But again, just make sure that these two things go together. So now if we look at our formula, P1 V1 over N1 T1 equals P2 V2 over N2 T2. And in this case, it tells us very explicitly we're assuming constant T and constant P. So that means that P1 and P2 are the same and that T1 and T2 are the same. So this is an Avogadro's law problem. And so if you're one of the ones that wants to take the time to memorize the formulas, you might have gotten to this a little quicker, but that's a lot of memorizing. So directly proportional again. And again, our volumes match, even though the unit's a little weird. We don't need to convert it to liters or milliliters or anything else. So we can plug in, and we need to find N2. So N2 is in the denominator here, and that does often trip people up. There are a couple ways to handle this. You can cross-multiply a ratio, so that's one option. You can also just invert the entire equation. So you can just take this and basically take the inverse of both sides, which is just the -1 exponent. And what that means is that N1 over V1 equals N2 over V2. So you can flip the whole proportion over and do it that way. And that puts N into the numerator for you. The other option is you can multiply both sides by N2 and then divide and multiply by the other variables to get N2 by itself. But regardless, now what I can do here is multiply both sides by V2. That cancels that out, and now I'm going to switch the sides and put the N2 on the left. And that puts N1 V2 over V1. And so you can see they're kind of cross-multiplied. The N1 is times the V2 now, so that's that cross-multiply thing if you do it that way. But anyway, you should get to there eventually. So however you do the algebra, there's 2 or 3 ways to get there, but just make sure that you're getting so that N2 is equal to N1 times V2 divided by V1. All right, so now we can finally plug everything in. So we have 1.10 moles. We're going to multiply by our V2, which is our 55. And then we're going to divide by our 26.2. Again, this is directly proportional, so if we want the volume to get bigger, we know we're going to have to add more helium. So this number of moles should get bigger. And if it doesn't, then you've probably made an algebra mistake or an arithmetic mistake somewhere. And sure enough, this comes out to 2.31 moles. So now we have actually two more issues left. Number one, we want our answer to be in grams. But the other thing is this question says how many more grams of helium must we add? And so we've already added 1.1. We need to get to 2.31 total, which means that we need 1.21 moles more. And we can do that subtraction now because the units are the same. And now we can convert to grams. Helium's molar mass is 4.003 if we go to the periodic table. And so I think the simplest way to do that, see 1.10, there we go, so 1.21, and then times 4.003. So we need to add an additional 4.84 grams of helium.